Figure 1 shows an argon diagram. The set P of points that lie within the shaded region, including its boundaries, is defined by this locus, where A, B, C, and D are integers. Let's write down what they are. So this locus is, clearly the region between two circles. So if we just focus for a minute on this, we're saying it's all the points that are greater than a certain amount, or if you set it equal, it'll be like on the circle itself. And we can see that the radius is just going to equal 1. So A equals 1. And then if I just look at the right-hand side and set it equal to D, so now it's less than or equal to D, but it's going to be talking about this bit here, or maybe I'll stick with making it horizontal. Now this is just 2, and that is going to be my value of D. The radius is between 1 and 2. Now it's just all about the center. So we can see that the center is minus 2, 1. But this then translates to B equaling 2, is the opposite, and C is going to equal minus 1. And there we have it. Those are our values. Now the set Q is defined by the same locus, but also the intersection then with this. Okay, so let's try and draw it out. It's going to be a perpendicular bisector because we've got these 2 points, and let me draw them on. So I've got just I, essentially. That's going to be here. And then 3i up here. And what I've got really is like, essentially the magnitude of complex numbers from these 2 points. So it's when you get them intersecting. So if I draw kind of this sort of thing, they'd intersect here and here. What you actually get is the perpendicular bisector between these 2 points. I haven't gone into, I tried to kind of just explain a little bit about it, but this is that locus, okay, to be aware of. So it's actually going to go through here. When it's equal, I should add, which means if I wanted to be closer to, or the magnitude of z minus I to be smaller, it's going to be closer to the minus 1 part, and therefore it's going to be everything below this line. But if I want to deal with the intersection, it's then going to be all of this. Essentially, the shaded region I had originally, but I need to subtract that segment, this green segment. Okay, let's sort this out. So first up, I'm going to work out the shaded region. I should probably add the gray shaded region because I know I've just shaded it in red. Well, that is going to be pi times 2 squared, the big circle, minus pi times 1 squared. That's 4 pi minus pi, 3 pi. Just got to subtract the segment now. And let's create a sector, because now my sector is made up from the segment, whose area I want to find, and this green triangle. So let's just sketch out what's going on. I've got a radius of 2, both. What I need is an angle, and I'm just going to draw across here and here. So I don't need to do, because this is not a right angle triangle, but I can split it down the middle and turn it into 2 right angle triangles. So this is 2. No, sorry, that is not 2, but that here is 1. So if I want to find the angle, then it's going to be tan, not tan at all. It's going to be cos of the angle is equal to 1 over 2. And then we can just do inverse cos, and that gives us pi over 3. Okay, I'm going to work in radians here. That's what you normally do. So that means actually, if I draw it out again, this in fact is going to be 2 pi over 3. And the area of the sector Well, you can, okay, there's a couple ways to do it. You might be familiar with the formula when you're working in radians. It's just a half r squared theta. You can just sub it straight in. So a half times 2 squared times 2 pi over 3. If not, don't worry, because that formula just comes from doing 2 pi over 3 divided by 2 pi, the full amount around. That's the fraction of the circle that we have. And then we times by pi r squared, so pi times 2 squared. So you can see that well, these two cancel, and we're left with 4 pi over 3 in both cases. This is covered in the second year available math, so I probably shouldn't have mentioned it here. But you can just write it straight down without, just this nice formula. So anyway, we get 4 pi over 3 for the sector. So now I'm going to look at the triangle. And I've got, remember this is 2. Now I don't know the base or anything, but I do know that this is 2, and remember this is 2 pi over 3. So I can just do a half AB sine C. These cancel, so it's just 2 lots of sine 2 pi over 3. I think this is going to be root 3. Because sine 2 pi over 3 is the same as sine pi over 3, which is the same as like sine 60, that is root 3 over 2. Times it by 2, we get root 3. And therefore the segment area is going to be 4 pi over 3 minus root 3. So finally, the exact area of the region, well, it's going to be our 3 pi that we have from before, but I'm actually minusing the segments. So I'm minusing 4 pi over 3, and then I'm minusing root 3 from that. 3 pi is just 9 pi over 3, so I'm going to get 5 pi over 3. And then it's a double negative, so I'm going to be adding root 3. And that is our final answer. Really nice question.